some of the absolute value functions now. Just a couple things. Think back to when we were doing like vertex form of a quadratic. Which of those two numbers was the one that we always made like its opposite? One of them became the opposite, the other one stayed the same. This one always became the opposite, and then this one always stayed the same. And the one that was paired up with x was the x coordinate of our vertex, so the -4 became +4. And then the number out here at the end was the y coordinate, and it always stayed the same. I want to remind you of that because even when we're dealing with absolute value equations, it's the same thing for the vertex. So for our vertex, this number here will become the opposite, and it will be the x coordinate, and then the one on the outside will stay the same, and that'll be the y coordinate. So my vertex for this one is also 4, -1. Quadratics had that U-shaped graph, the parabola. Well, absolute value, just think of it this way. Value starts with V, and it's going to make a V-shaped graph. Okay, so all of our points today will fall. Like, we will kind of do what we did with the parabola. We'll graph the vertex, and then we'll graph 2 points to either the right or the left, and then we'll just mirror them to the other side. But this time, they are all going to fall on a straight line to where we'll just be able to put a ruler down and we'll connect them. It won't be a curve like those quadratics are.
Wait, so how'd you get the points when you got them? Oh, you just -1 and up.
No, those points were already there. I'm going to show you how to get those points. The only thing I wanted to show you here was that in order to get your vertex, which is that bottom of the V right here, it's the same thing as what we did with quadratics when we were looking for the vertex. So this one's always going to become the opposite, this one's always the same. All right, so down at the bottom, for the parent function, okay, a parent function is basically the original, the starting point, the one where there's been no translations done to it. So basically it's just the absolute value of x. This would be our parent function right here. The domain, if we're allowed to plug in any number for x that we want, what were we writing for domain?
All real numbers.
We were putting all real numbers, right? Or we were putting the r. I want you guys to get in the habit of doing the negative infinity to positive infinity. So negative infinity to positive infinity. That means any positive or negative number that exists. So it's all real numbers. Now your range, remember with quadratics, the range, we'd always put the letter y. And if it was facing up, what did we use? Greater than or equal to. If it were facing down, what would we do? Less than or equal. Same thing is true with absolute value. Okay, it is facing up. This V is facing up, so we're going to put greater than or equal. And then what's that low point? Like, what's the low point? 0. It's the 0. And which way was this opening up? It was opening up. Okay? Down here at the bottom, it says the direction of opening is determined by the value in front of the absolute value, just like it was with quadratics. So when you look here, there's nothing in front of that, which means it's positive. And when it's positive, it's always going to face up. And when it's negative, it's going to face... Okay, good. Now turn the page. Now, I am really sorry about this. On your practice page, the lines, the grid lines will be there. I don't know what happened when I printed them off, but the grid lines on the graph just they were so light they wouldn't print. So unfortunately, we're going to have to just do a sketch. We're going to do the best that we can. But when you guys actually practice them, it'll be a lot easier. Okay, so we are doing the absolute value of x minus 1. That's what our function is. So right across the top in your little T-chart that we usually make, I am going to have you guys always start with the vertex, just like we did with quadratics. So what's the opposite of this number? What? Positive 1, so that would be the x. And if there's nothing out here, what number could we put there? We could put a 0. So your vertex, make sure you guys are listening, your vertex is always going to come from the function itself. Opposite, same. Opposite of this one is your x, and then whatever number's out here will stay the same, and that's your y. It's just since there's no number out there, we just put a 0. Okay? So go ahead and plot that. Plot the 1, 0. That's an easy one. Now you're going to do exactly what we've done before. Either 2 to the right, so we could do 2, 3, or what are the 2 to the left? 0 and negative 1. Which ones would you guys rather do? I'd rather do the positives also. So we're going to do 2, 3. So all we're going to do is we're going to plug in a 2 where that x is. So the absolute value of 2 minus 1. And then we'll do the same thing with the 3. These are pretty simple. What's 2 minus 1?
1.
And what's the absolute value? 1. 1. And what's 3 minus 1? 2. And the absolute value of 2 is 2. All right, now do your best. Okay, you might make little tick marks. Maybe that'll help you where all the numbers are. Maybe that'll help. But we're going to plot 2, 1 and 3, 2. Like I said, this is just a sketch, so we're doing the best we can. When you do your practice page, you guys will actually see your grid lines. Okay, now watch. Look, you guys should only have this side done. When we go to mirror them, if this is 1 to the right, I should have it 1 to the left. So it should be right here. It should be on your 0, 1. It should be right there on the y-axis. That this one was 1 to the right, this one would be 1 to the left. This one up here was 2 to the right, so we would need 2 to the left. So it would land at negative 1, 2. You're pretending like this. Look up here. You're pretending like you have an axis of symmetry right there through that vertex. That would cut it in half, just like it did with quadratics. So that's where I'm getting my mirrored. Yeah. So if that axis of symmetry helps to draw it, then just draw it. Yeah, there you go. I mean, we're doing the best we can since we don't have grid lines. But then you guys would just put your ruler down and connect your points. And every single time you do this, it should look like a V. Well, it should look like a V, yeah. Okay, so what did we see about domain? The answer for domain is always the all real numbers, so we're going to do negative infinity to positive infinity. Okay, now as far as the range, we know it's y, and is it facing up or down? So we're going to use greater than or equal because it's facing up. And then just go to your vertex, and what was the y coordinate of your vertex? The y coordinate of your vertex was 0. Now your y-intercept. This one you can actually see it. You can see it on the graph. Where did it cross the y? It crossed at 1, right? So my y-intercept would be 0, 1. Now look up here. If you could not see it on your graph, like let's just say later on you guys graph a picture. You like plot your points and you graph it. If you can't see where it crosses, this is how you guys are going to do it. Wherever we're looking for the y, isn't x equal to 0? So you're just going to plug 0 into the original function and solve it. If you can't see it physically on the picture, just plug a 0 in where that x is and solve. So what's 0 minus 1? 0 minus 1.
-1.
-1. And what's the absolute value of -1? 1. Okay, so I could have gotten that by just plugging in a 0 and figuring it out. But if you can see it on the picture, just get it from the picture. So I'm going to write plug in 0 where x is. That's how you do it. But every single answer today for domain should always be -infinity to +infinity. Your range will vary based on what the low point or the high point is. Okay? Is that okay? I actually think these are quite a bit easier than quadratics. They're easier to plug into the original because we don't have any x squareds. So this should hopefully be a little bit easier for you guys than those quadratics were. Okay, let's go down to this one. We're going to start with our chart. And the function is the absolute value of x plus 3. Oops, that's not. And then minus 1. Okay, now we can go ahead and get our vertex right away. Opposite, same. So what's my vertex? -3, comma, -1. So opposite of this, same over here. This is y, this is x. I don't know how many times I have to tell you that. Everybody, when I say what's the vertex, you guys should be able to just look at these two numbers and automatically tell me. Opposite, same. Okay? You don't have to fill out the middle section for that one. Now, plot that, so -3, -1. And if that dashed line will help you, you know, when you guys actually have a grid line there, it'll be easier. Right now, you just can't see the grid line. Do you want to use -2 and -1 or -4 and -5? Okay. It doesn't matter. You guys just pick two numbers to the left or two numbers to the right because we're going to mirror them anyway. All right, now plug this in. So -2 plus 3 in the bars minus 1.
-2.
Okay, hang on. What's -2 plus 3?
-1.
It's +1. What's the absolute value of 1?
Oh.
1. And what's 1 minus 1? 0. You got to remember, you got to do these in steps, right? So then this one, -1 plus 3 minus 1. So what's -1 plus 3? 2. What's the absolute value of 2? 2. And what's 2 minus 1? 1. Now when you guys are doing your practice page, this chart is there for you. It does have an X column and a Y column, and it also has a column in the middle for you to show work. But you never have to show work for the vertex column because we get the vertex straight from the equation. Okay, so we're going to plot -2, comma 0. Again, do the best you can without these grid lines. And -1, +1. So I'm just making little tick marks at each number. That might help a little bit, even though you don't have the full grid line. It might help when you go to plot your other points. Okay, so I've done the right side, so now I need to do the left side. Yeah, and -5, 1. Yep. And then connect them. you had this one, and then it looked like you had these two. You had this, right? So then this one would mirror over here, and this one would mirror over here. Like I said, it'll be a lot easier when your grid lines are there. You'll be able to see it better. Okay, so domain, automatically just write negative infinity to positive infinity. Now your range, was it facing up or down? So it's y is greater than or equal to, and then just pull the number from the y coordinate of your vertex, which is -1. And again, it's right there, so it's that low point. The range, the number you use for range will always be the y coordinate of your vertex. Now the y-intercept, look up here. I know that when I extended my line, it looks like it should be at the 2. But, you know, what if we accidentally just shift our ruler a little bit when we connect them? Like, we should probably double check and make sure that it really is the 2. So don't I just have to plug in a 0 up here? Okay, so that's what I'm going to do. I'm going to put a 0 plus 3 in the bars minus 1. And let's just make sure that we actually get an answer of 2. What's 0 plus 3? And the absolute value of 3. Absolute value of 3 is 3, and then minus 1 is 2. So my y-intercept would be 0, 2. So when you guys are figuring these out, if you could please look up at the board, always do this first, then take its absolute value, and then subtract 1. Like, you have to do it in 3 steps. This makes 3, the absolute value of 3 is 3, and then minus 1 gives you 2. You can't just do it all at once.
But how is x 0?
When you're looking for a y-intercept, it's always 0, something, because it's going to be on that y-axis. So the x-coordinate would be 0. Just like if you're looking for x-intercepts, the y is always 0. Like, to which one? Yep. Okay, so if you guys feel fairly comfortable, can you turn the page and try to start on the next one, like identify the vertex? I think is there only one left? Yeah. So why don't you just try that? Do as much of it as you can. Identify the vertex, come up with 2 other numbers you want to use, and just see what you can do. The one thing I know is everybody should get the domain right. All of us. You good now? Okay. Yep. Is there a number in those bars with x? So what would it be? 0. And then the y coordinate, 2. Yeah, so if there's no number in there with x, you're just going to have the x as a 0. There's no opposite of 0, it just is 0. Okay, so I'm going to plot 0, this one's the worst one. There are no lines. So I'm just going to make little tick marks to help me. Okay, so 0, 2 would be on the y-axis. What numbers do you want to use? Sure, 1 and 2. You could also use -1 and -2, but positives are always easier to deal with. All right, now look, When you plug in that 1, it goes inside the bars, but you still have, okay, what's the absolute value of 1? 1 times negative 2, and then negative 2 plus 2. 0. And then when we do the 2, what's the absolute value of 2? Times negative 2, and negative 4 plus 2. Negative 2. Yeah, those you're going to kind of just have to talk out to yourself, because if there is a way to do absolute value on our calculator, I don't know how. Like, I don't know how to put that symbol in there. We're just not going to do it. Absolute value is simple. You guys should be able to just come up with that and then figure out the math on your own. All right, so plot 1 comma 0 and 2 comma negative 2. And if you guys need a dashed line, do it, but your y-axis is basically the center, right? Mirror it to negative 1, 0, and then this one over here would be negative 2 comma negative 2. So you should have a V that is facing down, and the original equation had a negative out front, so it would make sense that this would be facing down. Domain. Yep. The range. Y less than or equal to this time because it's facing down. Yeah, so y is less than or equal because it's facing down. And then you get the y coordinate of your vertex, which was 2. Now your y-intercept was actually part of our graph. What was it? 0 comma 2. Yep. It was the vertex, wasn't it? Yeah. Now on your practice page, if you guys pay attention real quick, on your practice page, you will do the domain and the range. I don't think the y-intercept is on your practice page. So you will be given a function. You'll identify the vertex, plot it. You'll do 2 more points, plot those and mirror them, and then you'll answer those 2 questions. Okay? You guys have any questions on those? All right, then I keep those notes out while you guys are working on your practice page. And then whenever you finish the second practice page and you have the first one turned in, you'll be allowed to leave.